So what we're looking at today is solving systems of equations with three variables. Now, you've done systems of equations before, but they mainly look more like 3x plus 2y equals 15 and 7x minus 2y equals 24. Solved it in two variables, where we tried to get one of the variables to have the same number in front so we can eliminate it by adding or subtracting the two equations together, or by using substitution, where we get a variable by itself and plug it into the other equation to solve for the values of x or y. So that's not what we'll be doing today. Today we'll be working with three variables. Now, most likely we'll cover this again with two variables later on throughout the year, and it will be covered again in ACT prep, because we'll go back over how to do systems of equations with two variables in ACT prep. So what we're looking at today is solving systems of equations with three variables and being able to figure out what the values of x, y, and z would be to make all three equations true. Now, in any one that we solve, we'll have one of three solutions, one of three types of solutions. The first one is that we're going to have exactly one solution. There's going to be one point that is in common for all three equations or all three planes, because an equation with three variables represents a plane. And if all three planes intersect at a single point, that would be a solution to the system. It's this point. That point makes all three equations true. So we can have exactly one point, a single solution. Or we can have infinitely many. That line there would represent all the points that are true for all three equations. It could work out that we have more than one solution that is true, and it's defined by this line. Now, in this class, we're not going to get too in-depth on defining that line, because we can come up with equations that will define that line, and we could find any point on that line, because we normally denote it as A, give it a letter A, and any letter or vowel, or not vowel, value for A that we plug in would give us an ordered pair that works for all three. But this here we consider it to be infinitely many solutions. There's an infinite number of them. And the last type is no solution. Because we can see on the third one, those three are just parallel to each other. They do not cross at any point. So, okay, so there's not going to be a solution. There's no intersection. Now, even though the other two intersect down here, even though these two do have points of intersection, because it does not have an intersection of all three planes, it is still no solution. Because any point that we pick in those sets of intersections will not satisfy all three. It'll satisfy two of them, but we need it to satisfy all three. All three need to cross for us to be able to have a solution. So these three here are the three types of solutions that we can have for a system of equations in three variables. Now, with these here, there are some steps that we can do and we're going to do to solve the system. The first kind of main step is to rewrite the linear system in three variables as a linear system in two variables by using the substitution or elimination method. Solve the new linear system for both of its variables. Substitute the values found in step 2 into one of the original equations and solve for the remaining variable. Okay, let's get some steps, because that's all fine and dandy, but let's put it in a little bit in a way that we can kind of better understand. Our first main step is to pick an elimination equation. We want to pick one of the three equations we're going to use to eliminate a single variable out of all three. Our second step is to pick a variable that will be eliminated. Now, step number 3 is that we're going to eliminate that variable, whatever it is. We're going to eliminate it. Step 4 is to repeat steps 2 and 3, and step 5 is to solve backwards. Okay. Were we able to get all these steps down? Okay. Now, when we look at this here, now when we think back to geometry or algebra 2, how many variables did we solve at one time? What was the most we ever solved for at one time? 1. Because even if we had 2 variables in geometry, I know we had a few equations where we had 2 to solve for x and y. We never solved for them at the same time. We would find the value for x and then use it to find the value of y, or vice versa. We can only solve for one at a time. So even though we do have 3 here and we will find the values of x, y, and z, I cannot find them all simultaneously. I can't find them all at the same time. I can only find one at a time. So that's why we're using elimination. Because if I can take this down from 3 equations with 3 variables down to 2 equations with 2 variables, I can then take it from 2 equations with 2 variables down to 1 equation with 1. Then we can actually solve. So when we look at this here, the first thing it says, pick an equation to eliminate. Well, we want to pick one of these equations that will be easier, or kind of would be nice to use to eliminate a single variable out of the other 2. So 4x plus 2y. So if I picked x, well, I would want all the x's to be the same. Or if I picked y, I want to make it so that all the y's are going to be the same, or z, so that they're all the same. And I mean, if we're doing x, I would pick the 2x, because if I need to get them to be the same as the other 2, well, if I do 2 times 2x, I can get 4x pretty easily. If I wanted to make 2x into 6x, well, I can just multiply it by 3. That's kind of nice and easy to work with. And if we're doing elimination, we always want to make it go up. If we're going to try to get them to be the same, we want to go up. So I wouldn't pick 4x, because trying to get 4x and 2x to be the same means I'm coming down. It's a little bit harder to go down than it is to go up. Because, I mean, we would have to multiply everything or divide everything by 2. 4 divided by 2 is 2. That's fine. 2 divided by 2 is 1. We're good. 3 divided by 2, well, that's a fraction. We don't want to try to, I would want to avoid fractions at all possible. So it's easier just to multiply whole numbers to go up than it is to try to multiply by fractions and come down. Now, z would be kind of a little bit challenging for no matter which one we pick, because there's no good way to just multiply 4 and get 5, or multiply 4 and get 3, or 3 and 5, 3 and 4. Those don't work well. What one would work best? What's with y? One of them is going to be the best out of all of them, I think. 1y, isn't it? Because if I want to get 1y to be the same as 3y, I just multiply it by 3. If I want to get 1y to be the same as 2y, I just multiply it by 2. If it has 1 in front of it, that's the easiest one to work with because I can change it into any other number just by multiplying it by said number. To where with 4 and 3, I mean, those don't work well. I mean, we could get them to be the same number, but I have to multiply the 3 and 4 with our z's, both by a number to get them to be the same. One of the few that we can get it to be any other number. It works very well. So if I were going to do this, I would pick this bottom one to be our elimination equation. We're going to use it to eliminate y out of the other two equations. Now, because this is 1y, we don't have to change the other two equations for y to be able to eliminate out. We're going to just go on and put them down. We can say 4x plus 2y plus 3z is equal to 12, and 2x minus 3y plus 5z equals negative 7. Because we're going to take these two equations and use our eliminator equation to remove y from both of these here. Now the two we have listed, we don't want either one of those to be the eliminator equation because we're using it to remove y. Because if I use the eliminator equation on itself, well, that's just going to remove everything. It wouldn't help us. So what we're doing next is we're going to remove y. We're going to use the eliminator equation to take y out of these two equations here. Now the next steps that I'm going to write on the board, I'm going to suggest that you don't write them in the same spot. Write them off to the side. These are going to be our side work. And as y'all can see here, I really don't have space to either side of this here. So I'm going to write it below this here. I would suggest that y'all write it off to the side because we still have more work to do on this problem here. Now, any questions on this here before we start the next part? So what we're doing is we're taking this equation, 6x minus y plus 4z is equal to negative 3. Now we want this y to be the same as 2y. So what can I do to that whole equation to turn 1y into 2y's? We can multiply the whole thing by 2. Because what we're doing is scaling it. We're scaling everything up by the same amount. It's not changing the equation, it's just changing how it looks. So we can multiply everything here by 2. Well, 2 times 6x is 12x. 2 times negative y is negative 2y. And 2 times 4z is going to be plus 8z is equal to negative 3 times 2 is negative 6. Any questions on how we got this part here? Okay. Well, as I said before, I don't quite have space to leave this here. But what we can do is we can move this right under our other equation. So what did we want to have happen? We wanted what? The y's to cancel out, yes? So to do that, we've got the y values the exact same, 2 and 2, 2y and 2y. Now we're either going to add the two equations together or we're going to subtract them. So would we need to add these or subtract these to get the y's to cancel? So 2y minus, so if we said minus, what is 2y minus negative 2y? What's a negative and negative? Make a? So 2 minus... 2y minus... Yeah, so negative... Yeah, this would make a positive, which is 2 plus 2 is 4. Doesn't work, does it? So if we add 2 plus negative 2, 2 minus 2 is 0. So here we need to add. The way I think about it is if the signs are the same, negative and negative, positive and positive, then we subtract. If the signs are opposite, positive and negative or negative and positive, then we add. And really when we look at them and just make sure you're doing the calculations and just not marking it out because the numbers are the same, it'll tell us. Like we saw here, when we said 2 minus negative 2, we came out with 4. That's not 0, that's not what we wanted. So okay, we need to do the other operation. Because when we combine and do the elimination step, it's either addition or subtraction, it's one or the other. We're not going to deal with multiplication or division when we're eliminating the variable out from the two equations. So if we take on the rest of it, 4x plus 12x is 16x. 2 plus negative 2, or 2 minus 2 is 0. That's what we wanted. 3 plus 8 plus 11z is equal to 12 plus negative 6 is 6. So in doing this once, we now have a equation with two variables. So we're getting closer. Any questions on what we've done so far? So now we need to do the same thing. Take our 6x minus y plus 4z equals negative 3. And we're going to multiply it by something to get this y value to be the same as the other one. So what do we think? What would we need to multiply this, our eliminator equation? 3. Because we have 3y in the other one, so we need to multiply everything in this one by 3. 3 times 6x is 18x. Minus 3 times y is minus 3y, and 3 times positive 4z plus 12z equals negative 9. So we just distribute that 3 on both sides. And again, just like with the other equation, we'll put it right up underneath here.
So this one would be close?
Yes. Because negative 3 plus negative 3 is?
R0.
Negative
Wait, negative what? Did you say?
Negative 3 minus 3.
Oh, negative 6.
Negative 6. Okay, that didn't work. So it wouldn't be plus, it would be minus. There are some books that would tell us instead of just multiplying by 3, we would multiply like by negative 3 to try to keep it so we stay with the same operation, always addition or always subtraction. But this here isn't too big of an issue because, well, okay, I saw that adding didn't work. So we'll just go with subtraction. Because negative 3 minus negative 3, the negative and negative would be a positive, so negative 3 plus 3 is 0. That's what we wanted. So the subtraction is what we need for this here for those to cancel. So 2 minus 18 would be negative 16x. And as we saw already, the y's do cancel out. 5z minus 12z would be negative z is equal to minus negative 9. Well, that'd be plus. So we end up with 2. So we don't really have any like terms at this point because we do have two separate equations. So we've gone from 3 equations with 3 variables to 2 equations with 2 variables. So we've taken one out. Yes? So any questions before we move on to the next step? Well, not yet, because we've done steps 1, 2, and 3. Now we're on to step 4. Okay, so we need to pick a variable to eliminate out of both equations. Which one would be easy to do? 16x, yeah, 16x, because 16x is in both. Why not? Let's use that because it's the same in both equations. So at this point here, we can just bring both of them down because I don't need to change anything. They're already set up, ready to go because a variable has the same number before it in both spots. Now we just need to figure out if, for our elimination step, do we need to add them together or subtract them? So what's the sign in front of 16? The top one is, and the other one is? So if they're opposite, we add. If they're opposite, we're going to add. If they're the same, we're going to subtract. Because as we saw with the negatives, it makes the other one positive. Or if they're both positive, it makes one negative if we're subtracting. If they're already opposite, we just need to combine them. 16 plus negative 16, or 16 minus 16 is 0. These will cancel. 11 plus negative 7, or 11 minus 7 is z, is equal to 6 plus 2. So now I'm left with one equation with, how can I solve? Divide by 4. So z is equal to 2. And again, we have x, y, and z is 2. Now, step 5 wasn't just solve, it's solve backwards. So we have one variable's number, yes? Now, I can't use the original one because it still has 3. I only have 1, so we're still missing 2, yes? But let's go back up the page. Wait a minute, right here. Don't I have 2 equations with 2 variables?
Yeah, you could.
So I'm going to erase this here. So really, I could pick one of these 2 to solve for the value of x, because I know what z is. Which one do we want to use? It doesn't matter. We can choose the positive one. So I can say 16x plus 11 times 2 is equal to 6. So we can use this equation. So we can go on and solve. So we can do 11 times 2, which would be 22, equals 6. Then what would we do next? Minus 22 from both sides. These will cancel. Telling me that 16x is equal to what? Divide both sides by 16, which tells me x is equal to what? Negative 1. So any questions on how we solve for x?
Just go back to the original one and then solve it.
Yep. So that's why I say solve backwards, because we went just back up the page. Yes? Yeah. And that's why I say solve backwards, because essentially we just went back up what we had already. And it really doesn't matter which equations we use, because again, if this is a solution, it should be true for all of them. Okay. So which one of these three equations do we want to use to solve for the value of y?
We have to use the one that we took out.
Any of them. We can use the top one. It will work the exact same because you already got the value for y. Did you get the value for y? Okay. Go on and solve it out and see if we get the same thing. Plus 3 times 2 equals 12. So I'm just going to use the top one. Well, 4 times negative 1 would be negative 4. 3 times 2 is 6. Well, negative 4 and 6 are on the same side of the equal sign, so we can combine those. It would be positive 2. 6 minus 4 is going to be 2. Then we would subtract 2 from both sides because we want to get y by itself. So 2y is equal to 10. Divide both sides by 2 and so x is negative 1, y is 5, and z is 2. So that there is the solution. We get the same thing, Caleb? Yeah. So I can look. Yes.
-6, right?
Yes. So we would add it, which would give us 3, minus 2, which would be 1.
And then negative 1.
So which one did you choose?
I chose that one.
So it should be 4z. So 4 times 2.
Oh, 4 times 2. Okay.
So it should be 8, which would get you back. Any questions on this here? Question? Question? Well, we're going to look at more of these here. We're spending 2 days on this because we're going to do 3 of these today, and then we're going to do more of them tomorrow.
So do we not have homework tonight?
We will not have an assignment tonight. So let's... All right, guys, let's look at this one here. So, again, we're going to use the exact same steps for this here. Now, we want to pick an equation to eliminate a variable from the other two. Why not? It's got ones all the way across. 1x, 1y, 1z. That won't be too bad. So, let's take this one to be our eliminator equation. What variable out of the 3 would be easiest to eliminate? X, y, or z? Yeah, I like y. Because, I mean, we have y, 5y, and y. So one of them already matches up. Because the top and bottom equation already have y as the same value. So that means for us that I can take our 4x plus y minus 3z, and we already put the other, our eliminator equation, underneath it. Because the values for y, like we did in the first problem where we tried to get them to be the same, is already the same. We don't have to do anything to it, so we can go on and put it down. Now, since this one's already set up, ready to go, why don't we go on and do the elimination for it, eliminate y, and then we'll look at the other one. So we have positive y and positive y for both of these here, so would we add or subtract? Subtract since the signs are the same. 4x minus x. 4 minus 1 is 3x. Y minus y is 0, like we wanted. Negative 3 minus 1 is negative. And negative 6 minus 2 is going to be negative 8. So we have one of our two equations with two variables. Any questions on this here so far? Okay. Now we need to get the other equation. So we need to take our x plus y plus z is equal to 2. And we're going to need to multiply both sides by a scalar or a number, so the y's will be the same in 5. So again, make sure, especially on y'all's paper, you're not writing it directly underneath, because we're still going to work. So we want to eliminate y is what we chose. So I'm trying to get our 1y to be the same as our 5y. Huh? Yeah, the reason, yeah, okay.
Well, I didn't know what you could ask.
So I think when y'all multiply through, you got 5x plus 5y plus 5z is equal to 10. So let's line this up. Right under here. So are the signs the same or opposite for our y's? So we would subtract. Since the signs are the same, we're going to subtract. Oh, wait a minute. 5x minus 5x. 5y minus 5y. 5z minus 5z.
So we done this for nothing.
3 minus 10.
Get 0.
Is 0 ever equal to negative 7?
What is that word? No solution. No. It said no. I was like, what is that word? I was like, I hate it.
Because what that's telling us is that these two equations, x plus y plus z is equal to 2, and 5x plus 5y plus 5z is equal to 3, are parallel planes. They're parallel to each other. So there's no point that either two of these planes will cross. Now the other one, 4x plus y minus 3z is equal to negative 6, will cross both of them. But because, again, it doesn't cross all three do not intersect, there is not a solution that will work. So at any point in solving, you get a statement like this here, 0 equals a number. A statement that is not true ever, because 0 is never going to equal negative 7. It is going to be no solution, and we're done. Questions on this here? Okay, we have one more we're going to look at today.
What time do we get out of here?
We get out of here at 1:32. Okay, so that was it. We'll have to finish this tomorrow because it is 1:29. So this is where we're going to pick up tomorrow, and we're going to finish the rest of this year. So we'll do more examples of these in solving.